One of the most important and widely used topic in math is calculus. Today we will begin our journey to the world of calculus. We will start off with one of the prerequisites for this topic, limits. First of all, let's take a general limit notation. The way to pronounce this is limit of f of x as x tends to a is equal to L. What this actually means is that the value of the function fx becomes closer and closer to L as x becomes closer and closer to a. However, remember that here x is not equal to a. By finding the limit of a function, we only want to know what happens to the value of the function when x approaches to a and not when x is equal to a. To understand this better, consider this example. Here we have the function y equals x squared. So when x equals 2, y is equal to 4. Let's consider a small increment delta from x. So when x is equal to 2 minus delta, y1 equals 2 minus delta whole thing squared. So that will give us 4 minus 4 delta plus delta squared. Let this be equation 1. When x is equal to 2 plus delta, y2 equals 2 plus delta whole thing squared, that is equal to 4 plus 4 delta plus delta squared. Let this be equation 2. In equation 1 and 2, when delta is deleted, that is as delta tends to 0, we get y1 equals 4 and y2 equals 4. We can show this operation using our limit notation. So here we have the left hand limit. Limit of x squared as x tends to 2 minus delta. So this is the left hand limit. So that would be equal to 2 minus delta whole thing squared, giving us 4 minus 4 delta plus delta squared. So for the second equation, we have the right hand limit. So this is limit of x squared as x tends to 2 plus delta, giving us 2 plus delta whole thing squared. So that gives us 4 plus 4 delta plus delta squared. So this will be equation 2. When delta tends to 0, equation 1 and 2 become equal. So the limit of x squared as x tends to 2 equals 4. So here, since the left hand limit and the right hand limit are equal when delta is deleted, it means that the limit exists. So basically what has happened here is that the x coordinate 2 minus delta is squeezed from left to right and 2 plus delta is squeezed from right to left. Similarly, y1 and y2 are sandwiched to 4. So this method of calculating limits is known as the method of squeezing. So let's consider this function. So here we have a function y equals fx. So if we take the right hand limit of this, the limit of fx as x tends to 0, here the positive means that we are approaching it from the right hand side. So as we approach 0 from the right hand side, we get the limit as 1. If we find the left hand limit of fx as x approaches 0, here the negative sign means we are approaching from the left hand side. So as we approach 0 from the left, we get the value minus 1. So here the left hand limit and the right hand limit are not equal. Therefore the limit does not exist. So therefore we can conclude that the limit of a function f of x when x tends to a is equal to L only when the limit of fx as x tends to a positive is equal to L, and also when the limit of fx as x tends to a negative is equal to L. That is, the left hand limit and the right hand limit must give us the same value. So that was a basic introduction to limits. In our next video, we will learn about the properties of limits and how to answer questions related to limits. If you have any questions, please ask us in the comment section below. Until we meet again, take care.